In question 12, we're going to sketch each graph, then we're going to describe the domain, range, continuity, and where the function is increasing or decreasing. Using interval notation, there are many of you that I gave this verbal instruction. Make sure you're using interval notation, and you either just forgot or disregard those instructions, but please remember, I'd like to see all of these values in interval notation. So let's start off with graphing our function. So we have f of x, which is equal to a negative x to the fourth. I would start thinking of this in terms of my parent function of f of x is x to the fourth, which if we generate some ordered pairs, we want some control points. I said the minimum is 3. If you have a few more, it's a little bit better. The problem with the fourth power, if I do a negative 2 to the fourth power at 16, it's going to go off the grid. Negative 1 to the fourth is 1. 0 to the fourth is 0. 1 to the fourth is 1. 2 to the fourth is 16. So the parent function gets quite large in a hurry. But what we need to remember about when we graph these fourth degree polynomials is that this graph is a little bit wider on the inside and a little bit steeper on the outside. So if I graph the ordered pairs that I have here, at least the ones that I can, 2 goes way off the grid, and negative 2 goes clear off the grid. It's steeper on the outside, but then it's a little bit flatter. It's kind of that wide view. I have no idea what happened at that point. That should have been up here. Wider, and then it comes back up, and it's steeper. So that's our general appearance of it. So try to make it look a little bit wider in the inside than a general parabola, and a little bit steeper on the outside. Now, what is this negative 3 going to do, or what kind of impact is it going to have? Since it's outside the grouping symbol, that's going to be some type of vertical change. Now, we can think of it as 2 or just 1. This negative is a reflection across the x-axis, so we want to reflect across the x-axis. And the other thing is this 3, if we're going to look at that 3 separately, that's going to be a vertical stretch. Now if I do them separately, what it would do is it would reflect it down this way, first of all, and then I'd have to stretch it after that. I want to do both of them at the same time so I can get this y value coordinated right away. So since these are both vertical, since they're both outside the grouping symbol, I just have to take the y value times a negative 3. Well, that's going to make this monster number, it's going to be a negative 48. So that's not going to be very usable. But this one, this 1, 1, the negative 1, 1 is going to become a negative 1, negative 3. The 0 is going to stay as 0, because 0 times negative 3 is 3. This is going to be a negative 3, and this will be that monster negative 48 as well. So these aren't going to help us in our resketch here. But what it does allow me to do is find 3 control points that I can graph. These 3 right here. The negative 1 becomes a negative 3, and it's stretching it. It used to be 1, negative 1. We stretched it by a factor of 3. It used to be 1, 1. It's going to be stretched to a factor of 1, negative 3. And our order pair 0, 0 stays there. So it's still wide in here, and it's getting steeper on the outside. Steeper. I really want to see those control points here in your graph. Okay, so now that I have the graph sketched, it's the red graph that we're looking at. What is its domain? So I don't sit here and have any confusion. The graph that we're looking at is this one right here. The domain. There is no restriction on our domain, so we're going to go from a negative infinity to infinity on this graph for our domain. We're not dividing by 0. We're not taking the square root of a negative, so that should open up our entire domain to inputs. The range. If we look at our ranges, they only stay below the x-axis, so that means our ranges go as high as and including 0. You got to be careful with this because this is a square bracket. It actually achieves a 0, and then it goes towards negative infinity. So that's our range. Continuity. It's continuous everywhere, so I want you to tell me the interval in which it is continuous. Since it's continuous everywhere, it's continuous on the interval from a negative infinity to a positive infinity. Increasing. We want to state the interval in which our graph is going uphill or increasing. Well, this graph is going uphill from, on the interval, you got to think in terms of x. X is from a negative infinity to, up including, to 0. So as long as I'm going for x values that are from a negative infinity to 0, our y values are increasing and approaching 0. Whereas our graph decreasing is from 0 to positive infinity. So now if I use x values from 0 over to a positive infinity over here, our graph starts falling, so now it is said to be decreasing in that interval. when we do these intervals, we never include the endpoint where that changeover occurs. So it should just be a parenthesis on the 0, not a square bracket. So there's 12a.